Hi, this is Nate from the Show About Science. I'd just like to chime in for a second. So I've been branching out to other podcasts, as you know, like the Show About Politics and History. And this one is called the Show About Titanic. It's hosted by my friend Edward. I'm currently producing it. And this episode of it is really sciencey, so I figured all you Show About Science listeners would really enjoy it. And if you like it, make sure to subscribe wherever you listen to podcasts. So without further ado, here is the Show About Titanic.
Hello everyone, and welcome to the Show About Titanic. This is your host, Edward, and today we're going to talk about Halomonas Titanicae, the bacteria that's eating the Titanic. So let's jump right into this interview.
Hello.
Hi, Dr. Kaur. Welcome to the Show About Titanic.
Hi, Edward. How are you?
Very well, thank you.
So, I haven't done a phone interview with someone so young before. So, can I know a little bit about you?
Yes. I'm Edward, and I'm 10 years old, and I'm the host of the Show About Titanic.
Okay. So, how did you get interested in the Titanic?
I have a relation with the owners of the shipyard.
Oh, okay. Well, that's cool. So cool.
Do you want to start the interview now?
It's up to you. Are you
Okay.
Are you feeling okay? I'm okay.
Sure.
Okay.
So, could you tell our listeners a little bit about yourself?
Yes. My name is Bhavleen Kaur, and I'm a senior scientist at the Ontario Science Centre, where I develop science exhibitions. I have a master's degree from aquatic biology, and I acquired that master's in India. And when I finished my master's program, I was trying to see, what can I do next? And so I decided to apply for a PhD program here at Dalhousie University in Halifax, Nova Scotia. And I was accepted to the program in the Department of Biological Engineering. My supervisor was Dr. Henrietta Mann, and she had been part of the team to go to the Titanic and gather samples. So because she had been involved in that research, she offered it to me when I was planning what to do as my PhD research. She said, hey, here's a chance. Do you want to look into this? And so I studied a little bit of what rusticles were, because I wasn't aware of that. That wasn't part of my study before that. And I found it very, very interesting and very fascinating. So that's how I ended up studying Halomonas Titanicae.
Okay, so could you tell us a bit about Halomonas Titanicae?
Yes, so Halomonas Titanicae is a bacterium that is kind of like a rod-shaped organism that has these long hair-like flagella that it uses to move around. And we found it from the rusticles on the Titanic. So in 1991, they had an expedition that went down to the Titanic, and they found that there were sort of rust-like structures that were growing off the Titanic. And they looked like icicles, so they called them rusticles. And when we brought those during the expedition up to sea level, we also then gathered whatever was growing inside the rusticles. And so Halomonas Titanicae is one of those species that was found within those rusticles.
Okay, so what is Halomonas family?
It belongs to Halomonas Titanicae. That's sort of how they call it. And these are a bacterial group or bacterial family that has bacteria that are very halotolerant. So the word halo means salt. So these are very salt-tolerant or salt-loving bacteria. So salt-tolerant or salt-loving bacteria is what Halomonas CD are. And because this is Halomonas, we tested how much tolerance it has for salt. So it can survive up to about 25-27% salt levels. But its ideal conditions about 2 to 8% salt concentration, which is about the concentration of the salt at that sea level, but it's much more tolerant to salt concentrations as well.
So what was the other species found in those rusticles?
So a species level identification has not been done on any other organism from the rusticles. At this point, all we know is that what we found in the rusticle was lots of different types of bacteria, some that use oxygen, some that don't use oxygen, some of them make their own food, others derive their nutrition from other chemical reactions. We also found species of fungi living within the rusticle. So this is the only organism that we have detailed to the extent that we know the name of the organism. And when we were studying it, we also compared it to other known bacteria, and we realized that this was a new species. That's why we were able to name it Halomonas Titanicae.
So how do the bacteria survive on just eating metal? Like they need air down there.
Well, bacteria can be interesting. There are species of bacteria that don't need oxygen, but actually for this bacterium and for any organism that's living in water, oxygen is dissolved within the water, and that is a source of oxygen for organisms. So it's not that there's no oxygen or no air at the bottom of the ocean. So that's not what is kind of controlling them. What we were surprised about is we thought, it's the deep ocean. There won't be a lot of organisms. It's going to be a pretty sterile, almost like a desert-like environment. But when we went there, and actually I wasn't part of the expedition, but I'm just talking about in general, the scientific investigation of the space, they found that there was this kind of interesting rain of something they call marine snow. And these are little, other microorganisms. They're not bacteria, they're zooplankton or phytoplankton. So they're like sort of microscopic, but they're multicellular. And as they die or they clump together, they fall down. And it's almost like looking out the window when it's snowing lightly. That's kind of what it feels like when they rain down. And that is also a source of nutrition for all the organisms that live in that region near the Titanic. They also rely on this marine snow to provide nutrition.
So, do you think the bacteria can be useful for eating metal in landfills, like putting the metal underwater and then the bacteria just goes, oh, okay, I like this, and then it starts eating it?
Well, what I did as part of my PhD research was actually look at what this organism does when it's present next to a metal. So I took a few different types of steel and I also placed them in different environments. So I placed them in an environment where this bacterium wasn't present and an environment where this bacterium was present. In some places, I shook the medium that it was in, and in other cases, it was just sitting quietly and it wasn't being moved. So all of those things change what happens to the metal. Interestingly, when there's no bacteria present, the metal in seawater will corrode anyway. All kinds of iron in contact with water and oxygen will start to corrode. What happens when bacteria are present is they sort of change the way the corrosion happens. In some ways, they can sort of create a layer as a barrier between the metal and water and slow down overall corrosion, but then at the point of contact, they can even create more intense corrosion because of their own chemical reactions for survival. So if you look at a piece of metal where the bacteria were not present, it's very even, the corrosion. Whereas when the bacteria is present, you'll get lots of big pits and then these kind of formations that start to happen, these mounds, sort of like tube-like, knob-like things that are sticking out of the metal. So that's what the bacteria do. They sort of change that. And I guess if you put it in contact with other metals, that might start to happen. But the other thing unique about what we're looking at is that it's not just this one bacterium that's causing the formation of the rusticle. There were so many other species, and we have to think about them differently. We have to think about them as if they're all working together to do that rather than by themselves, because the environment is very, very unique. So some organism might be causing some higher concentration of salt to happen. Maybe the flow rate stops as the rusticle gets thicker and thicker, and that changes the environment, and then one other species gets more active. So you have to think of it as if all these organisms that live in the rusticle are kind of working together. So it may not be that one organism can do all of the things. Maybe they all work together. But this organism did interact with the metal and did affect the corrosion. Sorry for the long answer there, Edward.
It's okay, because I like long answers. So, had you found this bacteria on the other shipwrecks? Like in the Andrea Dora?
I haven't studied any more shipwrecks besides the Titanic, so I'm not aware that they found this species. And actually, I looked up the research, so I don't know that anybody else has found this species on other shipwrecks. But it's not that easy because of where these wrecks are located. The Titanic is almost 4 kilometers below the sea, and so it's not easy to access. So getting to species level identification with these is a very expensive endeavor. You have to get the samples, you have to isolate them, then you can culture them. And the other interesting thing is that the pressure down there and the conditions down there can be very unique. So sometimes organisms may not even survive when they're brought back up to sea level and studied. So all those things can affect what we can study. But as far as I'm aware, so far they have not found this bacterial species at other shipwrecks.
Okay, so thank you for joining us on the Show About Titanic.
Thank you, Edward, for this interesting interview.
There you have it, folks. The Show About Titanic is complete. Make sure you subscribe wherever you listen to podcasts. Hope you have a good day, and cut!